Attend! Hop!
In this video, I have an oscilloscope made by Tektronix, model 2235. This one is a military version made for the US Army. You can tell it by this marking here. The military version is slightly different from the regular 2235 model. I don't know if this specific one was serving in the infantry or the Air Force, so it is hard to tell if those two knobs were hit by a torpedo or a grenade. Before it ended up on my bench, it was powered and displayed signals on both channels. Before I power it up, capacitors in the power supply section will be changed, and famous, or rather infamous, RIFA capacitors will be replaced. Those are famous for blowing up without warning. Well, no surprise. After all, it is military equipment, even though they are safety capacitors. Full metal jacket. This is my scope. There are many like it, but this one is mine. My scope is my best friend. I must master it as I must master my life. Without me, my scope is useless. Without my scope, I am useless. I will also spray pots and contacts on switches. The last military sticker indicates that it was still in service in 2004-2005. Probably shortly after it retired. At ease. 2 screws from the back. There was also one at the belly. Back cover out. Push it out to slide the outer case off. And we are in. High voltage warning. Over 7,000 volts at the CRT. Even though it is disconnected from the outlet, the tube and capacitors may hold high voltage charge. Must be careful. Here the circuit board is discolored from the heat. High voltage sticker once again. To remove the power supply cover, undo one screw. It slides behind the chassis. And here is the section of 2000 volts. A multimeter with low Z function not only will indicate that a capacitor holds the charge, but it will also act as a bleed resistor, discharging it. The scope was not plugged for a few days, and it seems that all capacitors are not holding any surprises for us. I didn't discharge the CRT because I will not touch anything there. Safe to work on it now. Let's remove the power supply cage cover. To remove it, we must first disconnect this board from its rail. And the cage is out. It was attached at those points. With 2 types of small bolts. And here we have the power supply section. Under the filter you can see one RIFA capacitor, hard to reach. With time its casing cracks, moisture creeps in, and it goes kaboom. Another two RIFAs are hiding behind this black cover. Let's pop it. One sits down there, the other is visible here. Two screws here, this is a ground rivet. Two bolts and nuts hold the inlet filter. Now it is exposed. And we have the small board loose. See, cracked RIFA capacitor. And its twin brother. Those solder points are hard to reach. Let's use a wick. Time for small ones. Got it. And the second one. Hey, hard to say goodbye? All three ticking bombs. And the spots are ready for new ones. While waiting for replacement parts, I spray switches and pots. Metal shield covers calibration pots and switches contacts. Must be removed. Spray and turn. Another one here. The rail contacts. The cover is back. Infamous RIFAs. Small ones didn't bulge, but develop small cracks. The big one was destroyed while pulled out with pliers. But it is cracking open here. $2,200, but it reads over 3,000. The second is not better. Replacement. And it is within spec. Those are special type capacitors that can withstand, if I remember well, around 2,500 volts. Even though those are not polarized, it is a good idea to install them in the right way into the circuit to avoid interference. To test them, I use an oscilloscope and BNC cable with alligator clips. The idea is to connect the outer layer foil lead to the chassis. This way the capacitor will be picking up less outer noise. I set it at the lower voltage per division. Shorten leads, no interference. When I connect the capacitor to the leads and hold it in my fingers, the peak voltage is slightly less than 2 divisions. Yeah, the camera is cheating our eyes. It is a sine wave. Switching leads. Now I have slightly less than 1. The black alligator holds the outer layer lead. This one should be connected to chassis. For the new one, no difference. We can plug it in either way. Well, this is tight spot. At last, after 3 hours of aiming. And it is in. Hey, don't breathe fumes, huh? The twins. I must collect all clippings. Don't need any shorts here. Wash it. Done. Assembly. Sweet. Time for electrolytic capacitors. 40 years. Give a chance to youngsters. As per smart EEV bloggers' advice, I bump capacitance on those 6 from 840 to 1000 and doubled the voltage. The numbers are printed on the board, but not polarization. Just in case, I mark their position on the board and orientation towards the front panel. Those are marked on the outer foil. The red spot marks plus. And it is actually indicated on the board. Sweet. The first is in. Trim it. After all be soldered in, I clean the board and I brush it to remove potential solder splash. New electrolytic capacitors. New filter capacitors. This big can capacitor hardly ever goes bad, so I keep it. Didn't touch anything beyond the power supply section. Don't want to throw off any parameters in the scope section. Those 2 sets are not electrolytics and are matched, so no touching. Let's change the table lining. don't want to power it up on a solder-infested surface. Cover on the filter section. Power supply screen on. The power supply cover on the belly. Along here we have testing points for supply voltages. This small board goes back in. Here I have power bar with a switch to cut the power in an emergency. The generator will feed the signal. Protection. Power on. Switch on. And nothing happens. No smoke, no bang, no trace. On light lit. Beam find. It's alive. Channel number 1. Channel number 2. No channel number 5. I can hear some viewers telling me, come on, throw this junk away. There are new, smaller, more capable oscilloscope. You mean like this one? It is not an oscilloscope. It is a computer. Alexa, take it away. By the way, if you have those knobs lying around... Till next time.